Okay, so this video is just on some more examples of differentiating with natural logs. So here we go. Find the derivative of natural log of x quantity to the third power. Now notice that the entire log is being raised to the third power, not just the x. So I can't apply the power rule and bring the 3 to the front. So my only option here is to use a chain rule. So the outer function is x to the third. The inner function is the natural log of x. So if we do the derivative of the outer, evaluated at the inner natural log times the derivative of the inner, there's our answer. Okay, we've got the natural log of the square root of x plus 1. And before you take any derivatives, my advice would be that you go ahead and expand anything that can be expanded. So I'm going to first rewrite this as natural log of x plus 1 to the 1/2 power. And then by the power rule, I can bring the 1/2 to the front. Now if we take the derivative, it's just going to be 1/2 times the derivative of that natural log. Now that's going to be a chain rule. So we're going to have 1 over x plus 1 times the derivative of x plus 1, which is just 1. That cleans up to that. And you can distribute the 2 or not. It's up to you. Okay, let's do another one here. We have the natural log of this crazy expression. Before we do anything, though, let's take a minute and expand it as much as possible. So we have the natural log of x plus the natural log of x squared plus 1 quantity squared on top minus the natural log of 2x cubed minus 1 to the 1/2 power. So using the power rule, I'm going to bring that 2 to the front of this log and the 1/2 to the front of the other log. Now that it's completely expanded, take the derivative using chain rules. Make sure you see all the parts. Natural log of x is just 1 over x. 2 times 1 over x squared plus 1 times the derivative of that, which is 2x, minus 1/2 times 1 over 2x cubed minus 1 times the derivative of that, which is 3x or 6x squared. We clean that up a little bit, we get this. Okay, another technique that we can use for logarithms or with logarithms to help us is to use something called logarithmic differentiation. So let's say we have a function like this. Notice there's no log in this problem. But we have this crazy function, and if we were asked to take the derivative, we would have to use a quotient rule. But another option is to bring in or introduce a natural log by taking the natural log of both sides. And how does that help us? Now that I have that natural log on the right side, we can expand this the way we were doing in the previous problems. So I'm going to expand the right side. So notice I used a subtraction sign because of the quotient. The 2 here moved to the front of the natural log of x minus 2. And this radical turned into a 1/2 power, so it moved to the front of that log. Now we're going to take the derivative of the left side using implicit differentiation. So the derivative of ln of y, think back to last semester, that would be 1 over y dy dx. The other piece, we've got 1 over x minus 2 times the derivative of the inner function, which is 1. So that's just a chain rule, times 2. And then we have 1 over x squared plus 1 times the derivative of that, which is 2x, times the 1/2. So if we clean this up a little bit, notice those 2's cancel, and we get this expression. Now we have to multiply. We have to get the dy dx by itself, like always. So I'm going to multiply the other side by y. We get this expression. And we always have to remember when you do a logarithmic differentiation that you have to replace the y with the original expression. If you go back, y was equal to that x minus 2 quantity squared expression times the rest of it. Sometimes when you look in the book, they're going to distribute this. They're going to try to simplify it. This is good enough. You don't have to go past that step. Something like this. Not necessary. You could have stopped right here, as far as I'm concerned. Last example here. So they're showing you if u is a differential function of x, and the natural log of u is u prime over u. This is just the chain rule again. Don't get too hung up on this formula. Let me show you what they're doing. Let's say we have the natural log of absolute value of cosine x. The absolute value is only in there because you can't take the log of the negative number, so it's kind of a formality. But you're going to take the derivative using chain rule. So we're going to have 1 over the inner function, which is cosine x, times the derivative of that inner function, which is negative sine x. That just simplifies to negative tan x.